Assalamualaikum warahmatullahi wabarakatuh. My name is Batrishyia Aishah Binti Faisal, and I'm going to present about machine learning in healthcare with my teams. So let's start. So this is our agenda for the presentation. So starting from the introduction, managing records, predictive analytics, robotic development model, which is heart failure prediction, solutions, model purpose, data and features, sustainability improvement, and lastly, application in medical device. So let's start with the introduction. So for the introduction, in recent years, machine learning has revolutionized the healthcare business. So machine learning is being applied to several parts of healthcare, from maintaining medical information to advanced analytics on equipment and treatment for patients, as well as the usage of robots due to its capacity to analyze enormous volumes of information and identify trends. So these applications are revolutionizing the delivery of healthcare, which leads to improved productivity, precision, and result for patients. So next, I will talk about the current application, which is the first one is managing records. And the second one is predictive analytics on equipment. The third one is predictive analytics on patient care. And lastly is robotic in healthcare. So the first one is managing records. So to handle and analyze electronic health record, which is EHRS, and other medical data, machine learning techniques are being used. So algorithms like this are capable of extracting useful information from organized and unstructured information, such as history of patients, test findings, clinical reports, and professional observations. So machine learning algorithm can help determine trends, predict disease development, and enhance medical decision making by analyzing such information. So this allows healthcare professionals like doctor, nurse to decide on more knowledgeable and personalized choice about treatment, resulting to better outcome for patients. The next one is predictive analytics on equipment. So machine learning algorithm can be applied on medical equipment for maintenance, planning, and insight. So these algorithms are able to predict whenever problem with the equipment tend to happen through constantly monitoring device indicator and analyzing previous information. So this proactive strategy improve healthcare facilities in avoiding unexpected shutdowns, optimizing schedule maintenance, and lowering unexpected breakdown expenses. So based on prospective data, machine learning may also help improve the use of resources such as planning procedures and controlling room capacity. So the next one is predictive analytics on patient care. Machine learning is becoming increasingly important in predictive analytics for patient care. So machine learning algorithm can detect trends and predict patient outcome by analyzing enormous amount of patient data, such as demographics, medical history, genetic information, and real-time monitoring data. So this forecast can assist healthcare providers in a variety of ways, including identifying high-risk patients who may require intensive care, predicting disease progression, and even recommending personalized treatment options. So machine learning can also help forecast readmissions and identify patients who may benefit from early interventions, resulting in better resource allocation and patient care. So lastly is robotic in healthcare. So machine learning and robots are rapidly being used in healthcare settings where they provide a variety of benefits. So robot utilizing machine learning algorithm can help with surgical operation, allowing for more accurate and less invasive surgeries. It can analyze real-time information such as pictures and biological signals to offer important information to surgeons while enhancing the way they make decisions. In addition, robotic may perform repetitive operations in healthcare contexts such as medicine delivery and managing inventories, which can improve productivity and eliminating the potential of human error.
Assalamualaikum, and my name is Ayuni Syamimi Suhaimi. So I will present about development of machine learning model. So the title is heart failure prediction and problem statement. Determine the probability of longevity in heart failure. Research background: heart failure impact around 26 million people globally and is predicted to cost a total of 31 billion in medical expenses in 2012. In accordance with the latest research, approximately 1 of every 5 individuals will suffer heart failure at some point in their entire lives, and over half of these individuals will pass away within a 5-year period. Although it can accurately forecast cardiac failure and survival, ML is crucial in discovering hidden discrete structures and analyzing input. And for the solution, when contemporary medical technology is unavailable, early detection and prediction of heart diseases become increasingly difficult. And to address the issues, many researchers have created a heart diseases model for forecasting, applying various machine learning techniques for early detection and treatment. For the example, logistic regression (LR), k-nearest neighbor (KNN), and the support vector machine (SVM), decision tree (DT), for a random forest (RF), nav-based (NB), and artificial neural network (ANN) are all examples of machine learning algorithm. So we go for the model purpose. K-nearest neighbor. KNN is a non-parametric statistical method for classification and registration that is one of the simplest algorithm in data analysis. And we can see for the before KNN, the new data point, and after KNN, the new data point, they assigned to category 1. And for model purpose, SVM. SVM belongs to the class of generalized linear classifiers, which are distinguished by their ability to minimize actual error while also maximizing physical border area. So you can see for the class A, class B, and then you will have the support vectors and the margin. And then for the purpose system, in the flow chart, we can start with start, and then after that will be a data set, and third data processing, and then model building, and the testing, and then prediction of heart diseases, and the last one go for the output. Data and features. For the selection of our features, so features category, H, immediate action items is the age of the patient, and the type is a numerical, and this description to determine of a patient from 28 to 77. Second, sex of the patient, the type is a categorical, and the description to determine man and female. And then after that, chest pain type, and the type is a categorical, and the description is to determine chest pain type, either ASY, NIP, or others. Next, resting BP, which is a resting blood pressure. So the type is a numerical, and to categorize resting BP, around 120 or 80 mmHg. Next, cholesterol. For the immediate action item is a serum cholesterol, and type for a numerical. And for description is a serum cholesterol level represent amount of cholesterol in blood. Next, fasting BS is for fasting blood sugar, and the type is a numerical, and for description is a fasting blood sugar level is 99 mg per dl. Next, resting ECG is a resting electrocardiogram result, and the type is a categorical, and it is a non-invasive resting. 12-lead ECG can detect arrhythmias, coronary heart disease. Next, for the max HR, which is a maximum heart rate, and the type is a numerical. For the description, categorize 3 parts: normal, LVH, and RVH. Next, the exercise for immediate action item is exercise induced angina, and the type is categorical. For the description, category if it is a true or false. And the last one is the all peak, and the type is categorical. For the determine the all peak from 1.72 to 4.44. So it is from me. I will pass to the next presenter. Thank you.
I will explain about the tuning hyperparameter. The hyperparameters are optimized and tweaked using a cross-validation procedures. If the hyperparameter are tweaked or optimized, the machine learning algorithm are taught to perform better. First, here we have the electronic media record of the raw data, consists of the patient medical history, lab report, question and observation. Then, apply preprocessing to the data. Consists of the missing attributes, remove redundancy, suppression, feature scaling, and then prepare HealthCare dataset, where it's going to split into the training data and the test data. Inside the training data, we apply the machine learning algorithm, where it is a logistic regression, k nearest neighbor, support vector machine, decision tree, and the random forest. As for the test data, we apply a grid search algorithm, where it is a C solver, number of neighbor, C, gamma, kernel, criterion, maximum depth, minimum samples, leaf, maximum sample split, splitters, bootstrap, maximum depth, minimum sample leaf, a maximum sample split, and number of the estimators. Then, generated classification models with the hyperparameter tuning. After that, performing an evaluation, and lastly, coefficient matrix, accuracy, precision, recall, and F1 score. Possible deployment. As we can see here, this is the F1 score of the traditional and proper system of the machine learning algorithm. The comparison here is between the logistic regression, KNN, SVM, decision tree, and the random forest. The F1 score here contain of the training dataset and the test dataset without parameter tuning and with hyperparameter tuning. Next slide. Data and features, create protocol. The heart failure prediction dataset was imported using a pandas in order to prepare the data. Determine whether the data seems to be cross-sectional and either at a baseline or over a certain time. Conduct in-depth analysis of the information, covering an evaluation of the key elements of the research of the information acquired throughout each visit. Next, the heart failure prediction dataset was imported. This dataset combined 5 heart datasets with 11 provided features, making it the largest collection of the heart condition information accessible. 980 individuals aging from the 28 until to 77 years. Result: 410 individuals were categorized as having non-heart disease, while 508 individuals were categorized as possessing heart disease. Incompatible and repetitive heart failure prediction dataset. The data decrease algorithm efficiency. Remove unnecessary characteristic values and data before running algorithm based on the machine learning. The machine learning models require a testing and training using a data. During the data processing step, the model created using the training data was put into a practice to evaluate the information in predicting the heart failure disease. The 3 dataset selections were cross-validated. The model predictions are created using the test data, and a model performance can be assessed with a validation and training dataset. Next slide, data and feature. In feature category, contain of the all peak, ST slope, and heart disease. Next, in the immediate action items, contain of the all peaks, the slope of the peak exercise FT segment, and the output class. we have to type here, which is the numerical and categorical. Lastly, for the description, first determine the all peak from 1.72 until 4.44. Next, determine if the slope of the peaks is up or flat. Lastly, determine if the patient has heart disease or not. Improvement in the sustainability. First, reduce the risk. The machine learning minimize the medical error and adverse event by predicting risk and enabling the early intervention. It improves the patient safety, reduces the hospital stay, and mitigates the environmental impact of the healthcare complication. Secondly, improve decision making. Machine learning supports evidence-based decision making in a healthcare, optimizing treatment selection and resource utilization by analyzing the patient data and medical literature. It reduces the unnecessary treatments and adverse events, minimizing a waste and environmental impact. Lastly, we have improved diagnosis. Machine learning algorithm can enhance healthcare diagnostic, leading to early and accurate disease detection. By analyzing extensive patient data, including the medical records, lab results, imaging, and genetic, they can uncover a subtle symptoms and pattern.
So next, I will explain about the environmental impact. So the first one is optimize facility waste management. So machine learning optimize facility waste management by analyzing water usage, energy consumption, and material waste. It identifies opportunity for conservation, energy saving measures, and waste reduction, promoting environmental sustainability in healthcare. The second is optimizing hospital solid waste management. Machine learning optimizes hospital waste management by analyzing data to predict waste generation and improve recycling practices. This reduces the environmental impact and promotes sustainability in healthcare. And the last one is predict carbon dioxide emission. So machine learning predicts CO2 emission in healthcare facilities by analyzing energy consumption data, enabling energy saving measures, and reducing carbon footprint. So next, I will explain about the machine learning application in medical device. The first one is diagnosis identification. So machine learning in medical device improve disease identification and diagnosis by recognizing patterns and providing real-time feedback, enhancing device efficiency and patient outcomes. So the next one is patient engagement. So machine learning enhance patient engagement in medical device by personalizing interaction based on patient data, improving adherence and empowering patients in their healthcare journey. The last one is medical record management. So machine learning improve medical record management in equipment, automating processes and enhancing data accuracy for easier access during decision making, which is enabling personalized and proactive care. So this is our references that we use for this assignment, which is from based on Hashi E et al. Studies, Wang J, Givarinam and Harrison O. That's all from us. Thank you for listening.